In the second problem here, we're going to look at building the largest container possible with a set amount of material, so that we know we have a surface area of 42 pi feet squared, or square feet. We also know we want to maximize the volume. So this time, maximizing volume, which means volume is going to be our primary equation. So from our equations there, we know volume is pi r squared times height, and our surface area. Now, this has no top on it, okay, which means our surface area problem is normally two circles. In this problem, it's only going to be one circle because the two circles are the top and the bottom. So we're going to have one circle. So instead of 2 pi r squared, it's just going to be pi r squared plus 2 pi r h. Okay. We know surface area is 42 pi feet squared. So we're going to say 42 pi is there, which equals pi r squared plus 2 pi r h. Now, one thing I'm going to do to make life a little bit easier, all of these have a pi. They all have a pi. I can divide by pi, and they all go away. So I'm going to divide both sides by pi, making all of our pi's disappear, leaving us with 42 equals r squared plus 2rh. Now, I need to solve in terms of one variable. It's probably going to be easier to solve in terms of h than it is to solve in terms of r because r squared would be a quadratic, not fun to solve. So I'm going to start by subtracting r squared from both sides. Then I can divide both sides by 2r. And I'm left with h equals 42 minus r squared divided by 2r. This is what's getting substituted into here. So now I'm going to have volume, which I'm trying to maximize, equals pi r squared times 42 minus r squared divided by 2r. Now, I have an r on top, outside. I have an r on the bottom. Those are going to reduce. So I'm going to have volume equals pi r times 42 minus r squared over 2. And then I can distribute that pi r across. So volume equals 42 pi r minus r squared divided by, minus pi r cubed. You got to bring that to both those numbers, not just one, divided by 2. So this is my equation that I'm going to find the minimum of, okay? Honestly, you really didn't have to reduce all that stuff. If you were to just take and type this equation in the calculator as it is, it would still work. I do like cleaning the equations up. It is a good habit to get into, but it's not required, so to say. So 42 pi r, and we're using x equals r, minus pi r cubed divided by 2. Okay. If I look at my graph in my standard window, I probably am not going to see very much. I do know that my radius has to be positive. So I'm going to go here, make the radius positive, go to 10. That's just a starting value there. Minimum 0, and we're looking at volume. So I'm going to go ahead and make this like 200, see what we can see. Okay, so I've got a good looking graph. Right there is my maximum. So I'm going to go second trace, which is my calculate menu. Number 3 is minimum. Number 4 is maximum. We're doing a maximum on this one. Left bound, go to the left of your maximum. Just scoot it on over with the little arrow button there. Enter. Right bound, scoot right. Hit enter. Guess doesn't really matter. So you hit enter one more time. And there we go. We have X and Y. Okay, and remember, X and Y are stored Here, X is 3.74 and alpha 1 is Y is 164.566667. So, what do these values mean? Well, Y is our output. And in this case, our output is here. So that's my Y value. The X value is R. And so that means that my radius, to maximize the volume, the radius is going to be 3.742. Okay. And if I use that radius, then my volume is going to be 164.567. Now for height, to find height, we just plug our value in here. Now, if you have your calculator and you have X stored, it's very simple to do that. You just type in parentheses 42 minus X squared divided by 2X. That's one of the benefits here, is it saves that number for you. And look, it's actually the same number. It's actually the same number, 3.74165, 3.74165. So that's what we have. So that means that the height is going to be the same as the radius, 3.742. Okay, so there are my dimensions and all that fun stuff. The question asks us for what radius, it says what height and base radius will maximize the volume. So we found those two. And then what is the maximum volume? Well, that's what we found. These values here are the values that will maximize the volume inside of our cylinder.